use Laplace transform to solve the following initial value problem. So we got a fourth order differential equation and 4 initial conditions. So we apply or we take Laplace on both sides of this on this ODE. So take Laplace on both sides of the ODE. So we're gonna get Laplace of fourth derivative of y minus 4 Laplace of y triple derivative plus 6 Laplace of y second derivative minus 4 Laplace of y prime plus Laplace of y equals Laplace of 0, which is 0. So let's denote Laplace of lowercase y by uppercase y. I mean, that's how we write anyways. So using the table, so let me write down Laplace of this. Okay, we got quite a few terms for this, and Laplace of this, this, and this. I mean, this is just Laplace of y. So Laplace of fourth derivative of y gives us 1, 2, 3, 4, 5 terms in this way. Minus 4 times Laplace of third derivative gives us here 1, 2, 3, 4 terms, plus 6 times Laplace of y double prime here, minus 4 Laplace of y prime here, and finally the last term Laplace of y we are denoting by uppercase y, that equals 0. Now let's apply the initial values. So y0 is 0, so this is 0. Y double prime 0 is 0, so this one is also 0. So this is 0, and y double prime is 0. So y0 is 0, y0 is 0. And y prime 0 equals 1, y triple prime 0 is 1. So this is 1. So let me, at the same time, as usual, we can always factor Laplace of y, uppercase y, can be factored out from first terms. Here, from here, 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 and here. Okay, let's factor Laplace of y, which is uppercase y, out. That leaves here s to the fourth, here negative 4s cube, here plus 6s squared, here negative 4s, and finally plus 1 because y is out. And this is gone, so negative, this is 1. Okay, so this is 1, and this is 1, this is 1. Okay, so from this we get negative s squared, and here negative s, negative 4, negative 4s minus means plus 4s, and here is, this is 1, so plus 6 times minus 1, negative 6. Okay, and I almost missed here, and we have this is also 1, so minus 1. Okay, that equals 0. So let's simplify here, and we can move this over, and we can isolate y. Yes, that's Laplace of y is equal to, move this term over, which is negative s squared becomes s squared, plus 4s becomes negative 4s, negative 6 minus 1, negative 7 becomes plus 7 on the other side, all over this polynomial, okay, which is s to the fourth minus 4s cube plus 6s squared minus 4s plus 1. Okay, now to get y back, y is a function of t, we need to take inverse Laplace of this function, this fraction. So as soon as we get inverse Laplace of this, then we are done. Okay, so before we take the inverse Laplace, let's simplify this. Okay, let's factor the bottom, and this one negative 4, negative 4, 8, 6, 1, 1, 8. So this factors. Okay, we can factor this, and we have to do partial fraction decomposition here. Okay, so let me do that over. So the bottom factors, okay, and we can do synthetic division a couple of times, and we get s minus 1 to the fourth. Okay, and now from the partial fraction decomposition, we can let this be a over s minus 1, b over s minus 1 squared, cube, and up to fourth. Okay, and multiply both sides by s minus 1 to the fourth and find the values of a, b, c, and d. Okay, it takes some time though. And we get a 0, b equals 1, c equals -2, and d equals 4. So that means our y, which is Laplace of lowercase y, is equal to, this fraction is b over s minus 1 squared, which is 1 over s minus 1 squared, plus c over, which is -2 over s minus 1 cubed, plus d over 4 over s minus 1 to the fourth. Okay, note that the Laplace transform of Tn is in fact n factorial over Sn plus 1, and when we have, let's say, e to the alpha t times, then this s becomes s minus alpha. I mean, this exponential factor will shift this, so this simply becomes, instead of s raised to n plus 1, this will be s minus alpha raised to n plus 1. And we have that situation. Now we are going back, so we have this situation. So this s minus 1 because of the factor e raised to 1t, and these are something like 1 over n factorial over s. So let's fix that. So this is 1 factorial is 1 over s squared. That's good. This is good. So let me not do anything. Or this one is Laplace of e to the t times just t. Laplace of t would be 1 over s squared, but this et shifts that s to s minus 1 minus, so 2 3, so n factorial n plus 1. This is also good. So this is Laplace of 2 over s cube would be coming from t squared, but s minus 1, that's e 1t, plus here 4 means we need 3 factorial on the top. Okay, to match this, 3 factorial would be 6. So this one can be written as 6. I need 6, so 3 factorial 6, but this is 4, and I can multiply by, there is extra 2. Okay, and 2 over 3. Okay, 3 factorial is 6, and divide 6 times 2 is 12, divided by 3 is 4. So this 4 we can write in this way. Then I can apply this rule. This is n factorial over s minus s to the fourth. So that is 2/3. Let me put on the front. Laplace of 3 factorial means t cube, but s minus 1, that's the shifted from et. Okay, this is the case. Now we take inverse Laplace on both sides. Take inverse Laplace, then we recover the function y is equal to, inverse Laplace is also linear, so et times t minus et times t squared plus 2/3 et times t cube. Okay, we can factor et from each term, but this is at final.